So I worked on all digital cellular technologies, and I have to confess that I've also worked on some of the non-successful technologies like DECT and WiMAX, and so I know both sides of this successes, and that's part of what I would like to talk about here. So I will not talk a lot about technology and numbers. I have a few numbers there which I think have not been shown yet, but I would like to highlight a few key areas where I think we really need to put emphasis on, and then talk really about the process, that how to go forward. And my talk is titled Your Gigabyte Today, and I will actually come back to this U and Gigabyte in the talk. But let's first take a look back, maybe not 200 years back, so let's take a look back to LTE. So I would claim that LTE got it right. So LTE is growing faster than any previous mobile technology. Quarter by quarter it's growing faster in the number of subscribers than 3G, and this is a prediction by Strategy Analytics that where it took to reach 1 billion subscribers for wideband CDMA 11 years, it will take 7 years for LTE. And that's how it seems to be going. Also, another point, LTE was standardized fast and with good quality. There are various measures of quality. This is one measurable thing here. So if we look just at the corrections that were needed in the RRC, comparing wideband CDMA and LTE first releases, so there's a 1 to 3 difference roughly, or 1 to 4 difference. So we really got it right somehow. And we can ask that, obviously this is something we would like to do. We would like to do a system which is really successful, and we'd like to do a system which is good quality. So we can ask that, is it this that we had practice with 3G that made us perfect here, or was it just luck that we happened to get it right? And maybe it was that we actually just knew for once what we were doing. So we knew the use case, the killer app. Either you can think about it as the application, the access to internet, or the app economy coming with the Apple inventions. So we pretty much knew that. In contrast, in 3G times, this was not really known. Some may remember the early times of 3G, which kind of started from broadband ESD, and luckily we were able to kind of move it towards packet communication and internet, but it was a creaky process, and we needed to do a HSPA iteration to get it right, or close to right. Also, we knew the technology to optimize the interface. There had been a lot of research over years and testing different technologies, time domain, CDMA, OFDM, whatever. And we knew actually that with OFDM and single carrier FDMA uplink and short framing, we could fulfill well the requirements for this use case. So, and we also knew how to simplify the architecture to get from these multiple boxes to just 2 layers before getting to the killer application, the internet, so the base station and the gateway on the data plane, to reduce latency, to improve or reduce complexity and improve performance. So this was a case that where we fortuitously knew the use case, which seems to be still holding very well, and the technology pieces that we could deploy. And that's how we got it pretty right. So let's then see that, are we clear what 5G should do and how it should do it? Let's take a look. First of all, so we can ask that, who are you in 2020 plus? Okay, most of us will be human still, at least in this room, I think. And it's clear that there will be autonomous machines. So machines that are given tasks and they will carry them out, and they will need connectivity for that. And then it's a good question, will we have independent machines? I liked it when I think Misha asked in the panel yesterday that when are we going to have dating services for machines, and somebody answered I think 5 or 7 years. I think that's a little bit early, but maybe 15. So, but anyway, in the next decade we could have independent machines, and which is a big leap forward again. And it's not at all clear that who are the users going forward. And then coming back to humans, so how will you connect? So kind of do you think that kind of 10-15 years from now the preferred method is still poking at the screen? Maybe that's so intuitive that you have been flipping pages for hundreds of years, so maybe the flipping of the screen is kind of going to be with us a few tens of years. But we could maybe be communicating with the blink of an eye, much less obtrusive. Or we could have some telepathy with a little help. That is from a Duke University experiment where they actually have pretty much proven that with some electronic help, mice can communicate telepathically even across continents. And so it's, I think, the connection methods also for the future. We have very vague idea what the connection methods will be 10, 15 years from now. And we need to take this into account. And and I don't even want to touch that. What do we as humans want to do? So like social media, which I think is part of the value bits we discussed yesterday, because there's not so much bits unless you upload your videos there, but the main content is not so much bits, but it's extremely valuable for people. Derive young people from their social media and they go crazy. So what are the new things that will be there in the future? So for humans, I don't want to touch on that too much because it's clearly impossible to predict. But let's see, what could a machine then want if we would have these autonomous or even independent machines? So it actually is quite different from human. A machine, so a computing system, that can consume any amount of data in a short time. For example, downloading a database or new software program for some task that it needs to perform. It might need gigabits or gigabytes in a very short time. Something that humans just can't consume, but machine can easily consume. It can also produce any amount of data in a short time with high definition cameras and other sensors, etc. And definitely we had a lot of talk, and I very much liked that we have been about the talk by Professor Hetweiss. I had an interesting talk afterwards with him. We've been working on this low latency. And for humans, it's clear that we need to go below 10 milliseconds, maybe even 1 millisecond, but it's clear that machines can go easily under a millisecond in their reaction time. So for them, there is actually no lower limit for need of kind of short latency. And machines don't have need for clumsy interface like smartphone. They are telepathic by nature. They communicate directly between the kind of concepts and programs. On the other hand, we have been, most of the machines that have been so far talked about here are these dull M2M types which sleep for months and then send a byte now and then. So there's a huge variety of use cases for machines. So it's clear that both from the previous on the humans and this on machines, we need to look beyond the current human requirements for future communication systems. And I think we are just groping in the dark there, trying to feel the elephant in the dark there. So my first claim here is that we have very little idea what the requirements of use cases will be, let's say 10, 15 years from now, the new ones. But I think that we can still think about some things that we need to do. Because we don't have really a good feel for the use cases, it's clear that we need to build technology which is much more flexible than today. And now I jump a little bit beyond radio, away from radio here, because I think that it's clearly that this virtualization and flexibility will first start to happen on the core on the service core and packet core side, and radio is the last one. And what I mean with this, that we already have the compute and storage clouds virtualized and performing any tasks, and it's clear that also network will need to move in the same direction towards a network cloud where we have virtualized the resources and we have a software-defined network. But for some service providers, they probably will try both things, and then they can actually combine this so they can have the whole service delivery machine end-to-end, both the connectivity and all the computing under one control, and basically provide the best end-user performance that way. So virtualized software-defined infrastructure, that's pretty clear that that's one of the things that we need to do to survive with the requirements that we really don't know at the moment. I think Prana will talk later today about how to actually do this. So I'll leave that to you. So going forward then, so we discussed who are you in 2020. My talk was your Gigabyte in the future, and or beyond. So what do we get with a Gigabyte a day? And we can get quite a lot. For example, 300 songs, 200 photos, and 200 PowerPoint presentations like this, and I think maybe somebody could consume or produce 200 photos or flip 200 photos easily a day. So, and 300 songs a day, that's serious consumption, so maybe not really. And of course 200 PowerPoint presentations a day would drive anybody insane, so we don't really want that, but that's kind of doable. Let's jump a couple orders magnitude forward. So what do you get with the Gigabyte a day? You get 20% of a popular Linux operating system. Well, that's fine. We don't need a new operating system download every 5 days if things go well. So that's not a problem. We get 20% of a popular visually oriented game. That's probably okay. You have to be a pretty hardcore gamer to kind of continuously go through a new game every 5 days. Some people can do that for a period of time, but still probably okay for a Gigabyte a day. Let's again jump forward. It's 5% of a Blu-ray HD movie. And okay, maybe you want to watch a movie more than every 20 days or so, so that starts to be pushing the Gigabyte. And it's only 5% of a day's TV in high definition. And obviously, kind of either you cut down your TV watching habits, or you don't do it over wireless, or then something has to change. But clearly, a Gigabyte a day is actually shrinking when we go to more demanding content. And more demanding content here is video, moving images. So I think that even though we don't know so much about the future, just because of video, and there are other high bandwidth applications which we might not even imagine, but just because of video, we know that one future requirement is that we need to massively improve capacity. And this is a discussion which or talk that has been here many times presented. So I don't go into too much of the details, but I would like to fix still some numbers here, because many people talk about 1,000 times capacity or similar numbers, and I would just like to make sure that what we are talking when I or our company talks about 1,000 times capacity, we're actually talking pre-5G. So 5G will bring more if we ever manage to do 5G, but we are talking about actually what happens between 2010 and 2020 and capabilities, not necessarily the traffic growth itself will be 1,000 times. There's a huge, this is again one thing which we need to understand, that there's a huge variation. I've been talking to a lot of operators, big and small, and some are convinced that their traffic will grow from during this 10 years we are in the middle of now, will grow about 30 times maximum. And then I have others, even some big operators, who say that, well, 1,000 times is kind of right ballpark. So there's kind of 30 times difference between what the operators think that the traffic will grow during this period, and this makes it, of course, quite challenging to have a uniform solution for everybody. But we think that this 1,000 times can be managed even without any 5G. So if we look at the spectral efficiency first, coming back to the discussion we had a little bit previously, at the 2010, when mobile broadband really started, we had a 3G core band was getting really into use, and the data consumption really started ramping up fast. The spectrum efficiency of HSPA was about 0.8 bits per second per hertz. We know that with LTE advanced 4x4 MIMO, we get to roughly 4 bits per second per hertz. A comp will bring us some more when we do it right, like we are now trying to again improve on in 3GPP. And then actually some things which don't really need standardization, like device interference cancellation, will bring quite a lot more. So we'll get to somewhere like, pretty sure we'll get to somewhere like 6 to 7 bits per second per hertz. And we think that it's possible to have some further innovations, so we can actually stretch the current LTE probably to around 8 bits per second per hertz. So we are actually kind of somewhere near the 10 times spectral efficiency compared to the HSPA we had in 2010. And then how much 5G will go beyond that? That's a good question, and that's what we need to look what's possible together in the various research programs where we are participating together with many of you here. The small cells I'll not really talk too much. I think that we haven't talked enough here about the real issues. So small cells, it's not really a problem to develop a small base station and with low power consumption and small size, but the real issues are low-cost deployment, low-cost management, backhaul. How do you do all those so that it actually is a reasonable business case to deploy these 10 times outdoor small cell base stations? The indoors will need 100 or 1,000 times more, and there maybe we can rely at least partly on the business or the facility owners that they do part of the work and part of the cost. But the operators need to do the outdoor a lot, and that needs radical cost reduction and new innovations, not just in the air interface and not in the base station, but in the all the things around it for really to happen. That hasn't been discussed so much, but that clearly needs to happen. Another thing which I'd like to point out that the small cells don't just boost capacity. So this is kind of macro cell starting point, and when we introduce higher spectral efficiency, the whole kind of capacity layer goes up, and we improve capacity. But when we add small cells, especially when we position them right, we do not just improve the capacity, we also improve the cell edge performance even further. So it's really also making the performance and the quality of experience for the user more uniform, which is important. So going forward, just one slide on what we think that a kind of 5G could be. So my current thinking is that actually for wide area, LTE is pretty good. I'm looking forward to the academians here and that what actually could be radically improved in a macrocellular system that we could not do with LTE evolution, backwards compatible evolution. So so far I haven't seen a big enough step change to think that a wide area system would need to be something else than basically LTE advanced. Maybe, but I'm hoping that somebody will think about something that is a good, is like at least 2 times improvement over that. So LTE evolution seems to be good for wide area, but it's clear that we can optimize for really dense local area radio. We had yesterday discussion here about whether Wi-Fi can do it, whether LTE is fit for small cells. I think the consensus seems to be going in the direction that LTE is not really the best thing for really super dense small cell deployments, especially if we think about spectrum sharing also and possibly partly unlicensed spectrum. But also many people, and there was a division here, I noticed that many people think that Wi-Fi will not really make it either because mainly of the MAC issues. Some people were more optimistic about IEEE, and actually I don't care whether it comes from 5G, 3GPP or IEEE. So if the IEEE seems that they will be going in the right direction, so let's move there and do the small cell standardization there. But obviously I think that so far the 3GPP way has really been working excellently for the industry, so that would be preferable. But about the system, so a small local area system for really dense deployments. These numbers have been around, so I just showed them that we are thinking similar numbers as others. 10 gigabit per second, 1 millisecond round trip time seems to be kind of getting towards some consensus here. Always connected with low overhead. This is very important because of the massive connectivity and the small packets. And low cost, low power consumption are given. On this power consumption, because of the time limits, I didn't have anything specific here. But I think, again, we don't need a miracle technology here. We have looked at it, and we're pretty sure that 100 times traffic growth we can manage with the same power level, same energy consumption as is currently. So so that's doable, and we can show that how to do it without any new kind of fancy technology. It can be pretty much done with the current technology evolution. So it's that we can pretty much take care of. Then we need, and here we come back to this, that if we really want to solve some of the issues, like for example the backhauling issues, and if we really want to solve some of the cost issues in the deployment, we think that we need a fluent support in the new system for access, backhauling, and device to device, so that we don't have different interfaces for different purposes, but this is more or less one system where you drop the small cells and they install and communicate. We need also flexible uplink, downlink duplexing for flexible use of the bandwidth, flexible use of spectrum, and then the millimeter wave spectrum, which has been also mentioned here several times. So this is what we think a good potential for new, massively more spectrum. So that's just shortly, and then I would like to switch gears a little bit and come back to this you part of your Gigabyte. And I think this is an issue which we don't pay enough attention to. Is it really your Gigabyte, this Gigabyte you're consuming? We have done a study a couple of years back on privacy issues, and 40% of the people responding to this study said that they are happy actually to give some use of their data and their usage patterns in exchange for getting more personalized, more contextually correct services. So that looks good. So okay, maybe we're not too worried about it not being our Gigabyte, or at least not totally our Gigabyte. Some people maybe take a peek at it also. But actually these same people, about 80% of them also see privacy as a very important topic. They're concerned about privacy violations, and they are afraid of their personal data being sold to third parties. So it's clear that people are okay with when they use a certain service, that if they feel that they get good personalized service, okay, so I can share some of our privacy, but definitely they are very unclear and worried about, okay, what else happens with this data and these rights to my privacy which I gave out. And when you look, when you kind of join some of these app store or social media site, who reads all these pages of the agreement there, some part of which is privacy? So it's pretty clear that we need to take privacy seriously, and I think this is something which we as an industry need to really put effort on also. And when looking into these same surveys, so what the people really expressed is that two very simple demands. They want to see who has got what of their personal data. So they want to have some idea what's around there, and they like to control the usage of that personal data. So nothing too fancy in principle. But this is very difficult in practice because people don't really understand all the issues. You need an army of lawyers and technicians or technologists basically to kind of really figure out what's happening with all the data and try to explain it to the people. So as an idea here, could we as an industry help users manage their privacy? This is something which we have been doing as a test, developing an identity management system which basically offers a portal where subscribers can manage their privacy across multiple applications. So they don't need to look at the different rules and different cases in all these systems, but they basically have one simplified set of privacy rules which they set and which are then propagated to these systems. So this is kind of early trial, and whether this is the right way to go is a question, but I think that this privacy along with security is something we really need to put more effort in when we go forward. Just summarizing a little bit about the requirements, again to have a kind of share that are we on the same page with you here. These are our current requirements towards 2020 as of today. So this support of up to 1,000 times traffic I talked about already, 10 times more users by 2020, maybe 100 times beyond that, but that's our guess. Enable really these gigabit per second peak speeds already before 5G, reduce latency to milliseconds, and then to 1 millisecond with 5G if we do that. Improve the energy efficiency, that's clear. And then coming back to one comment yesterday, it's clear, which again we haven't talked about here really too much, and I don't have time to talk now, but it's clear that we need to make the networks more self-aware, self-adaptable and intelligent themselves. Otherwise, it's not going to be economically feasible to manage the multi-layer, multi-technology networks that we are building now. And it's not actually going to be able, even no matter how many humans you put on the problem, you're not really going to get the performance out if you don't have massively better automation in the networks, like self-organized networking. And then coming back to this privacy issue, so we really need to deliver safe and superior customer experience, of course. We shouldn't forget the end user there. So concluding, coming back to this, that do we know what we do? My claim is that we are nowhere as clear as we were 10 years ago when starting kind of 4G, thinking that about the use case, and neither about the technologies to make a really significant leap forward in performance or other features. So the crystal ball is quite cloudy. The good thing is that I don't think we are in a big hurry, as we have a good system in use already. We have LTE for wide area and for small cells, maybe not the super dense small cells, but for at least for first phase of densification. And we have femtocells and Wi-Fi for indoors. So we actually have a pretty good pedestal. I think that we can for some time take our time and look and try to figure out this cloudy future. So let's not rush into a 5G, but make sure that we understand and share the demands and technology enablers. This is nothing new. This is how we have been doing the generations beforehand. My claim here is that we are a bit early in the stage, and it's excellent that this meeting has been organized. We need more meetings like this to discuss the issues, come to this shared conclusion, to be able to really repeat the LTE kind of success and really deploy a system which fulfills the new demands and which is of good quality and simple, I hope also. To take things forward, the last thing I would like to make here is a practical proposal. So it's clear from many talks that one of the potential technology enablers is new spectrum of that about 10 gigahertz. We don't know too much as an industry about really the propagation and channel at those frequencies for access systems. And so we propose to set up a forum to share plans, what kind of measurements people are planning to do in these millimeter waves, and share also results for these propagation studies. And we would offer to facilitate that kind of forum. I think this is part of the common understanding, building understanding that what is the real opportunity at these millimeter wave frequencies, are they really usable, what can you do with them? This is some of the things we need to share as an industry to be able to really then build on that and decide that is it really feasible actually to go, should we start developing technology to use those, and what kind of use cases we can support with those. So I'd like to leave you with this practical proposal and offer here and end my talk here. So thanks a lot.
So thank you, Lauri, and we will think about your proposal here. I also agree that there is a lot of open questions on higher frequencies here. So we have questions.
Yeah, a quick one, a little following up on the theme of yesterday, and perhaps even joint question to the previous speaker. When we talk about expanding traffic by a factor of 1,000, my assumption is the willingness to pay is more or less the same. So the implicit assumption is that you need to cut the cost by something like near 3 times every year for the next 7 years. Do you have any sense where the technology is going to come from to achieve such a heroic cost reduction?
Yeah, I think that with the current technology that we have at our disposal now, it should be possible for operators to offer, looking at the whole network cost, to offer a gigabyte for about $1 or less than €1. We have looked at this study quite a lot. I've seen papers from some other people in this room also who have come to very similar conclusions independently. So I think that that's one part. So that takes us a long way there. And it's not about technology, it's about the operator being able to plan their network and get enough, not too many, but enough users into a network, so have the right loading, because if you have empty mobile broadband cells, it's going to be vastly expensive. So, but it's doable in our view.
Thank you. And John?
I have a question about local area networks. You mentioned that you see that indoor there will be super dense local area networks. So my question is about, is it multiple local area networks, or do you see shared infrastructure, or where possibly where you can also share spectrum?
Yeah, the flexible spectrum usage, which I mentioned, includes sharing spectrum. So we need to develop technologies for sharing spectrum in an intelligent way between operators and between other systems also.
So that implies that there will be shared infrastructure.
Yes, I believe also so. So we, for example, we already have a very nice indoor solution which apart from not doing really MIMO, but these, for example, leaky cables, which are shared infrastructure and where you can very easily share between multiple operators. So that's a very nice indoor solution currently, and we'll see similar sharing in the future also. Yeah.
I think we had one question here, and then so perhaps you can start then, Claes, and then it's Professor Rafasuli.
Yeah, thank you for your presentation. I just wanted to challenge your conclusions, and I think twofold. And first of all, that's because I have teenage kids, and 1 gigabyte per day is nothing today for teenage kids. Now we have to remember that the teenage kids will be around 20 or so when these. Then the systems that we talk about are being launched, which is first of all. So my son, who is 13, he typically downloads on his his Samsung about 1 gig a day today, and all his friends do that. So that's the behavior that we should look at. Sort of us middle-aged men, we are not a group of interest to study our behavior. It's the teenagers. So that's one thing. And the other thing that also strikes me is that we all talk download here all the time, and we discuss things about stadiums, for instance, and we follow the traffic at the new Friends Arena, and we have seen two different traffic patterns. One model is like the Zlatan versus England model, when the stadium is filled with middle-aged men, and there's only download, and the download is before the game starts, in the intermission, and after the game. And then I have the One Direction traffic model. Everybody who has a teenage daughter knows what One Direction is. One Direction is the most popular boy band around the world right now. So 2 weeks ago, we had One Direction playing at Friends Arena. There were 50,000 teenage girls. That was only upload. So uplink is the main problem. And as far as I see it, it will not be solved with any MIMO systems, because I don't see that within 5 or 10 years we have MIMO uplink in handsets with the current electronics that we have available for RF today.
Okay, thanks. So maybe answering the second question first. So actually we have seen in the stadiums filled with middle-aged men also this upload behavior when there is a goal, for example. So it definitely is there, and we of course need to develop solutions for, and are developing solutions for that prior to 5G. But that's a very good observation, definitely uplink, and that's one reason why in this 5G we had this flexible uplink download, because we need to take care of switches. It's not static. It depends on what's happening in the environment. Then the other about this 1 gigabyte a day not being enough. I agree. So that's why I showed that, for example, video content, clearly it's not enough. So there are examples already. So I agree. So it's just a number to or to kind of work around, but whether it's the right target for a certain date, that's a good question. We need to again work together to find out.
Okay. No, just for your information, I want to say that we are in 5G IC. We're gonna conduct some channel measurement for 8 and 60 gigahertz.
Okay.
Understand it better for mobile, for both backhaul as well as the
access,
radio access.
Okay.
My question was, what is your view about the fixed network? Will it change the system architecture in the next 5-7 years time, or you're using that the flat architecture is going to stay with us?
You mean is it going to change the mobile architecture?
The fixed mobile.
Yeah. So
SAE architecture.
So. That's a good question, and it comes back to, like, if we just we did quite a study a couple of years back also with some people in this companies in this room about what are the needs to improve the core architecture, SA architecture, and looking at from the kind of just if you look functional point of view, mobility management, etc., there actually were not big needs for change it. Obviously, you can have other mobility management models, and maybe we'll have a talk later about other possibilities. But it seems that it works pretty fine, and there's nothing radically better. But then, on the other hand, there are coming these changes from this virtualization and software-defined, which you could think that okay, that's more an implementation issue. But again, actually, if we look that how would we build the SA architecture if the starting point for the implementation would not be kind of boxes with interfaces, but rather shared data and shared computing, then that may actually lead to quite big changes.
I have one additional question about your 10 times 10 times 10. Is the law of physics says that you go smaller, you go to the more you go to the smaller cell, or you do densification, the path loss law changes.
Yes.
And you don't get linearly increasing in the capacity as you were projecting. So have you considered that?
Yeah. So this
are not mutually exclusive.
I totally agree. And this 10 times 10 times 10 for us, which we introduced over 8 years ago, is more like the order of magnitude. We were looked at it, and there are obviously very different use cases. We have done much more detailed modeling on real cities, real traffic patterns, etc., which is on the background. So this is just a kind of summary of that to show that it's possible to get 1 times. I think our friends in San Diego have recently had a series of seminars on 10 times 10 times 10 where they went into great details to show actually how it exactly is done, and which was great. But for us it's not the kind of one truth. Obviously you're quite right about that. The small cells, the capacity is different, and with the large cells, when you have different propagation, you have kind of walls and things like that, so it changes. Yeah.
We have one question over there, and then the final two.
Actually, more like a comment. So I liked very much this sort of bringing up this uploading, because I was actually missing when we discussed about this machine to machine yesterday. This sort of consideration that actually camera is a sensor, and we will see a huge amount of cameras, and not necessarily operated by humans, but there's lots of data in the future. And that is something that we should also kind of consider now from the requirements point of view. And I'm happy that Lauri took it up, that it's not human behaviors and humans uploading the content, but there's this sort of machine-to-machine aspect.
Thanks.
So, and the final question.
Thank you. I think it's important sometimes also to really face the real trajectory in the history, to kind of draw prediction and learn lessons. Because the fact was that I think 10 years ago, this time, if you look around the world, I was still based in US at the time, but if you look at around the world, the ones that are seriously working towards the ITU numbers, 1 gigabits per second, 100 megabits per second, new air interface, new system design, were Japan, Korea, and China. They each had their different proposals and different approaches. At the time, US, there was very little activity actually towards 4G. And in the European community, my recollection at the time was that the focus was on heterogeneous network integration. There was really not much of a effort in new architecture, new air interface, and so on, as much as today we are working on 5G already altogether globally. So 10 years ago, the world regarding 4G was not quite coherent and unified. And what really happened, I think you said you work in both WiMAX and LTE, of course. So part of the story you are very aware of is that the emerging success to come of WiMAX became a major pressure for our industry. And not only that hastened our step, but also we learned a lot from the mistakes, the errors that the WiMAX system had already gone through. That's why I think that's part of the reason why we have much fewer corrections in the LTE standards in the process compared to the previous generation of standard. So my question is, given that experience and lesson, we are now very early stage working on 5G, especially as you were saying that primarily the new need would be in the local area. So what would you think that the Wi-Fi community activity would play a role in this? And how do you think our community should engage the IEEE AO 2011 community in this effort?
Okay, so I think some of the companies here are participating quite a lot in Wi-Fi development also, and have been. So for them it's natural, and they're working on both sides. And so far I think that the Wi-Fi progression has been kind of these bit rates and then adding features that we already have in cellular, like better authentication, mobility, etc. So nothing so spectacular. Now there's a new working group on this high efficiency wireless LAN starting, and that is going to be very interesting to look where that in which direction that goes. It could go that it goes in the same direction, and then we need to really look at how to cooperate. If it still stays more on this, that okay, let's not touch the Mac, etc. So then I think that there's not yet a kind of touch point. Of course, we can influence. We could all jump in there and start pushing things, but at least I'm not too in the direction. But as I said, I think that 5G or 3GPP direction has been good for this industry, so we should look at that. And then also, as I said, we are not in a hurry yet. We don't really know the requirements, etc. So I would not be pushing any standardization in either community very fast forward now. But I'm very interested to see what the kind of Wi-Fi development is going forward, and then we need to kind of see also how to cooperate.
So thank you again.
Thanks.